Many ionic compounds do not just exist in a laboratory or in your chemistry homework. Sodium chloride is regular table salt. Sodium fluoride is added to some toothpastes to help strengthen tooth enamel. Ammonium nitrate can be used to fertilize plants. Although their real-life applications are very different, they share a few key properties. In this lesson, we will learn about the properties of ionic compounds. These ionic compounds have very high melting points and are brittle because of their 3D giant ionic lattice structure. The strong electrostatic attractions holding the 3D lattice structure in place mean that a lot of energy is required to overcome these attractions. When we apply a force, it breaks the regular repeating pattern of oppositely charged ions, causing ions with like charges to come close to one another. The ensuing repulsion breaks the lattice structure. Sodium chloride, sodium fluoride, and ammonium nitrate can all dissolve in water, as we know. Or else we wouldn't be able to flavor our soups, brush our teeth, or fertilize our plants. Most ionic compounds are soluble in water. In water, an ionic compound can dissociate into its ions. So when we dissolve sodium chloride, it will dissociate into sodium and chloride ions. These ions become stabilized in water due to the polar nature of water. As you can see, the sodium ions are stabilized by the negative dipole of water, and the chloride ions are stabilized by the positive dipoles of water. This solvation stabilizes the free-floating ions. An ionic compound dissolved in water can conduct electricity. This is another key property of ionic compounds. This is made possible due to the presence of free-floating ions. We can dissolve copper 2 sulfate in water in a beaker. Add a few drops of sulfuric acid. Place a strip of copper and a strip of zinc into the solution. These will act as electrodes. Using 2 alligator clips, connect one strip to one end of the mini light bulb and another strip to the other end to complete the circuit. You will see that the light bulb lights up. Hence, this solution conducts electricity. Following on the same idea, molten ionic compounds can also conduct electricity. The lattice structure is broken at high temperatures, and so the ions become free-floating. In summary, ionic compounds have high melting points, are brittle, and can conduct electricity when dissolved in water or molten due to the presence of free-floating ions.